Hello, and welcome to our webinar, Coding Concepts. Special thanks to the Government of Canada for funding this initiative. My name is Danielle Ings, and I'm an education specialist at MindFuel.
And I'm Karen Sandhu, also an education specialist with MindFuel.
In today's webinar on coding concepts, we're going to be discussing the logic behind coding, using examples all in block, covering concepts such as sequences, loops, conditionals, functions, and variables, and then discussing debugging in block.
Let's begin today's webinar with an overview of the mindset needed before beginning to code. As smart as computers may seem, the fact is they cannot think for themselves like humans can. And we're not referring to AI or artificial intelligence here. Computers are only able to carry out commands or instructions that have been given to it. This can make them more efficient than humans, but not necessarily smarter. Humans will often bring in prior knowledge, which helps inform them when carrying out instructions. They might draw on this if they notice any gaps in the instruction and fill them in themselves, or add additional steps as needed, because they have an idea of what the instruction is meant to entail. This differs from a computer. A computer will only execute the commands it's given exactly as it is. This difference is important to remember when we're beginning to write code. This leads us to what is known as computational thinking. Computational thinking is an approach to problem solving that involves breaking down a complex problem into smaller steps, analyzing data to find patterns, using abstraction to focus on the most important parts, and finally, writing an algorithm or step-by-step sequence to model a solution to the original problem. It's a good idea in practice to develop a computational thinking mindset before getting into coding. Be sure to check out our webinar on computational thinking on MindFuel's YouTube channel for more information and some unplugged activities on this problem-solving approach.
Okay, so now jumping into some programming concepts. A programming or coding language is a set of syntax rules that define how code should be written and formatted. Block-based coding focuses on using blocks that represent various commands or programming instructions. Putting together a code sequence requires stacking or connecting the blocks together that relay the commands. Block-based provides a more visually stimulating atmosphere and predetermined representation of functions. Text-based coding, on the other hand, uses only text for programming instructions. Certain syntax needs to be understood for text-based programming, and there are specific abbreviations used for various programming outcomes. Text-based offers both a beginner up to advanced opportunities for programming, and once you understand the syntax requirements for writing statements and functions, it is very efficient in method. Some examples of text-based code languages are Python, JavaScript, CSS, HTML, and a few others too. Our first concept is sequences. In simple terms, a sequence is a series of steps to be followed. It is also known as an algorithm. In programming, a sequence or algorithm is the order of commands that a computer will execute one after another. Sequences can also be observed in our daily lives. An everyday life example is brushing your teeth. The steps need to be done in a particular order or sequence, otherwise the task would not be executed correctly. What would happen if the steps were rearranged for brushing your teeth? For example, if step 1 and 5 were swapped, that would result in your teeth not getting cleaned and toothpaste being wasted. This example shows that it is crucial that the steps in an algorithm are performed in the right order so that a computer can carry out the solution. As we mentioned at the start of the webinar, humans bring prior knowledge and experience when following steps to carry out an action. Computers do not have this ability, however. A computer will only do what is programmed to do. If the steps are programmed in the wrong sequence, the computer will still execute them. At this time, we ask you to pause the video and think of 3 everyday examples of sequences. Now let's look at an example of sequences in both block and the text-based. Here, the blocks you'll see are from codingville.ca, a game-based coding platform, and the text language is represented in JavaScript. We will be focusing in block code mainly, but we want you to start looking at the way that it is written in text-based as well, to start familiarizing yourself with the syntax. As you can see here, a sequence is represented by placing different blocks, one on top of the other. The blocks will be carried out from top to bottom, or in text, line by line. Now here are some connections of sequences to different subject areas for the classroom. Using these connections is a great way to integrate coding concepts to your everyday curriculum without even needing to get onto a computer. This can help you and your students establish a coding mindset early on. Looking at a few examples here. In English, writing a short story is a good example of a sequence, as the character follows a particular sequence of events in the plot. Or if we're looking in social studies, identifying the sequence of events that lead to world wars.
The next concept we'll discuss are conditionals. Conditionals are used regularly in programming and are the way in which a computer makes decisions. Conditionals involve evaluating a particular situation, also known as a condition, as either true or false. Based on this, an action will be taken. If the condition is true, then one action is taken. If the condition is false, a different action will be taken. This condition is often known as a Boolean condition, since it can have 2 possible outputs, either true or false. We participate in this type of decision-making process regularly in our daily lives. For example, when deciding what to wear based on the weather, we say, if it's cold outside, then I will wear a jacket. Otherwise, I will just wear a t-shirt. In most programming languages, conditionals are represented using the words if and else, which you can see highlighted on the slide. At this time, we ask you to pause the video and think of 3 other everyday examples of conditionals. Here we've shown how conditional statements are written in both block and text-based programming. In the block example, the condition that's being checked is shown in the orange block. This condition will result in being either true or false. It's important to note that conditionals utilize something called operators, which are used to compare the value or values against the condition. In the table, you can see a list of various relational operators that may be used when writing a conditional statement. So some examples include is equals to, greater than, less than or equal to, so on. In our example, the relational operator that's used is the double equal sign. This operator checks to see if the value on the right side of the operator is equal to the value on the left. If it is, the Boolean condition will evaluate as true. If, however, the value on the right is not equal to the value on the left, the condition will evaluate as false. For the example shown, the block of code under the do section will only execute if the condition is true. This example shows that if the cell color in the game is equal to green, then step forward twice. Here we've shown an if-else statement. In this example, our condition is checking to see if the number on a cell is greater than 100. If it is, the coding blocks under the do part of the loop will execute, meaning the computer will rotate right and take a step forward. If the value is not greater than 100, the coding blocks under the else section will execute, meaning the computer will instead rotate left and take a step backward. Here we've shown some connections of conditionals to different subject areas. So, in English class, we use conditionals when dealing with rules in spelling and grammar. If we're writing a person's name, we capitalize the first letter. Or if it's the end of a sentence, then we use a period. In math class, we say, If the angle of a triangle is equal to 90 degrees, it's a right triangle.
Moving on to another concept of loops. Loops are the idea of repeating instructions or code. Loops can be either repeating the same step or a group of steps over and over until the condition at which it is told to stop is met. In text-based programming, these are usually called while or for loops. A real-world example of a loop is the idea of walking. You are going to continue the repetition of taking steps forward until you get to your destination. Or until you have reached your destination, continue taking steps forward. At this time, we ask you to pause the video and think of 3 everyday examples of loops. Let's start with a while loop. In the block example, we see a while block being used along with an orange condition block. If the condition evaluates as true, then the code block under the do part of the while block will be executed. This will continue until the condition is no longer true. This example shows that a robot will be stepping forward as long as the cell color of the path it's on is blue. Now here we've shown the example of a for loop. If we take a look at the text, however, we see the conditions that are implied by the block code. The condition is as long as the count is less than 3, we will continue to move forward. In the for loop statement, the count has been set to start at 0 and count up by 1 until it performs the loop just 3 times. So now here are some connections of loops to different subject areas. In math, the steps included in long division repeat themselves until you have successfully developed the quotient, therefore creating a loop. Or in music, looking at the structure of a song, a basic arrangement is typically sectioned and loops between a verse and a chorus.
Our next concept is variables. A variable is a container that can hold a piece of data. A helpful analogy for this is thinking of a moving box. You can put certain objects in the box, and you label the box with the type of materials that go inside. Variables in programming will have a name called an identifier and may have a value assigned to it. For example, back to our moving box analogy. Kitchenware will all go in one box, and you would label the box kitchenware. The label or identifier tells you what it is that you're storing inside the box. This is the variable's name. Let's say the box contains 12 items. This would be the value. Variables are useful in programming because they allow us to change the value of the variable easily as needed throughout the program. For our kitchenware moving box, we could add more items to the box or remove items as needed. When programming, the value of a variable can be a number or a string of characters. For example, we can have a variable called name that would contain a string of characters representing someone's name. Or we can have a variable called age, which would contain a number representing the age of somebody. At this time, we ask you to pause the video and think of 3 everyday examples of variables. Here is how we would create and use a variable in both block and JavaScript. When writing code, the value of a variable is assigned using an assignment operator, also known as the equal sign. In our example, we can see that this sets our variable, called x, to a value of 0. We are also changing the value of the variable. Specifically, we're increasing the value by 1. We can see this with the statement x equals x plus 1. Here we've shown a few connections between variables and different subject areas. Math is one of the most common places that we use variables, but we can see them in unexpected subjects like English or social studies as well. In social studies, we may use a variable that represents the population of a country.
And finally, our last concept is functions. Functions are a great tool for a programmer as it is another method for saving them time in writing out the same code sequence. A function is a section of the program that performs a specific task. It first needs to be defined at the beginning of the code and then can be called on at any point. It saves the coder from writing the same sequence over and over and allows them to make a change in one spot and have it apply to multiple cases without having to search through lines and lines of code. Languages can have preset functions that are set, or you can have user-defined functions, which are what the coder makes up themselves. At this time, we ask you to pause the video and think of 3 everyday examples of functions. Now, looking at our example of functions, looking at the block of code, you can see that a function named Lados was created and defined here. This is shown in the red block section. This function contains 4 coding blocks, telling the computer to perform the task of stepping forward 3 times and rotating right. Now, this page just shows creating a function. Once this function is defined, as in the slide before, then all you have to do is call the function name and it automatically applies the sequence of steps it contains. So if later in my code I wanted to use this function, it simply needs to be called by writing the function name, Lados, and it will carry out the steps that were defined in it. This concept saves time for the programmer by only writing one line of code, the function name, as opposed to writing out each step of the sequence each time. Looking at the example code, what shape will be created or drawn by the computer when we are calling the function Lados 4 times? Feel free to pause the video and go back to the previous slide. If you answered a square, you are correct. The computer will rotate right, step forward 3 times, then repeat that sequence 3 more times. Again, here are some classroom connections to the concept of functions. In science, for example, carrying out the process of dissolving. This is a common task that often needs to be done when performing experiments and will consist of the steps: add solute to solvent, agitate or stir the mixture, add heat. Another example is in general having classroom routines or procedures for starting or ending the day in which the students know the actions that they have to carry out. For example, when you say pack up.
We're going to finish today's webinar with a short discussion on debugging your code.
Troubleshooting in block is definitely less intensive than when it comes to text, as the blocks are preset to represent the coding step itself, and you don't have to worry about syntax creating an error. Nonetheless, it is important to emphasize the idea of coding mindset or debugging logic here. Understanding how the sequences of blocks is connected or stacked and what is represented by each block is where the troubleshooting comes into play. Debugging the code requires the coder to execute each block step by step to ensure the end goal is being met. The coder needs to know the difference between an if and an if-else statement, or how a while loop is executed, for example. They need to be able to look at the sequence of code and match it to the task at hand. It's also important to know when to use efficient code, for example, when to use a function or a loop to help save some time and steps.
Let's take a look at the sequence of code presented on the screen. Are you able to work through it to determine what the value of count will be at the end? And what square the robot will be on? In order to answer these questions, you'll recognize that you have to walk through the code line by line. Let's take a few moments to do that together. To begin, we have a variable called count, and it's set to be a value of 0. Then we see a while loop with the condition count is less than 9. The coding blocks in the do section of the while block will be executed as long as the condition is true. The robot will take a step forward, and the value of count will increase by 1. This will happen again and again until count is equal to the value of 9 and the robot is on the green square.
That is all for today. Thank you for joining us. Again, my name is Danielle Ings.
And I'm Karen Sandhu.
And we appreciate you learning about coding concepts today.